In this lecture, we are going to learn about one of the interesting search technique called as the binary search algorithm. We are going to demonstrate the working of binary search. We are going to devise our own logic to implement the binary search, and finally, we are going to implement the binary search and see if we get the correct output. So let's get started. Before we start with binary search, there is one very important assumption that you need to note down. Binary search algorithm is applied only to the sorted element, right? Whenever your array is already sorted, that means the element in your array must be arranged in the ascending order or in the descending order, and in that case, if you would like to search for an element, you can use binary search, and that gives you the best result. Okay, so let's take the example of this book. This is a book wherein there are page numbers, right, starting from page number 1. Okay, now these page numbers are sorted in ascending order. Okay, page number 3, page number 4, page number 5, up to the last page number, which is page number 26. Okay, so we are going to demonstrate the working of binary search in this particular book, but before that, let's try to demonstrate the working of linear search in this particular book. Let's say I'm supposed to find out page number 21 in this book using linear search. So what you do in linear search is very simple. You flip to the first position, you get page number 1. 1 is not equals to 21, so you flip to the next page. 2 is not equals to 21, flip to the next page. 3 is not equals to 21, flip to the next page. 4 is not equals to 21, flip to the next page. So keep on flipping your pages like this. 20 is not equals to 21, flip your page one more time. Now 21 is equals to 21. So you have to perform 21 different comparisons to actually reach to this page number 21 using linear search. Now let's try to do the same thing using binary search. Now how you do in binary search is very simple. You have already implemented binary search while searching for a word in a dictionary. So what you do is, you're searching for 21, you don't know where is 21, so you flip this book in the middle. So divide this book into two parts, two equal parts mostly. So I divide it here, so I reach to page number 14. Right? So this is page number 14. Now I am searching for 21. So now this book has been divided into two parts. This is the left hand side and this is the right hand side. Now my page number 21 is there in the right hand side of this book because 21 comes after 14, and I know that this book is already sorted by page numbers, right? So I'm guaranteed that page number 21 is there in the right hand side of this book, so I do not need the left hand side of this book. So what I do now is I actually tear off the left hand side of this book because I don't need this book. Okay, so I divide this book into two parts, two chunks, the left hand side and the right hand side. Okay, so this is left hand side, this is right hand side. I do not need this part because 21 is in this part, so I'll just throw away this part. So now my problem size is reduced to half. I have done one comparison. I'll repeat the same process again. I'm searching for page number 21. So I divide this book into two parts. Okay, I just try to divide this into two parts. I reach to page number 23. So this is the right hand side and this is the left hand side. Now my 21 is less than 23, so 21 must occur in the left hand side of this book. So I tear this at the middle. Okay, so 21 is here, so I do not need this part, so I throw this off. Okay, so now I make a search for 21 in this particular chunk of a book. So I again flip it at the middle, right? So I flip it at the middle, I reach to page number 19. 21 is on the right hand side, so 21 must occur in this part. Okay, so 21 must occur here. So I do not need this part, so I'll throw away this. Okay, so I'm remaining with this chunk of the book. Again, I am searching for 21, so I flip this in the middle and try to see for 21. And now I exactly reach to page number 21 and my element is found. Right? So at max, by doing 4 or 5 comparisons, I'll be able to reach to this particular page number 21 using binary search. But if I'm using linear search, I'll have to make 21 comparisons to reach to page number 21. So this is the advantage of binary search, and binary search is very efficient search algorithm whenever your array is already sorted in either ascending order or in the descending order. Okay, so demonstration is over. Now we are going to now devise our own logic to now implement binary search. Before we devise our own logic for binary search, let us find out what is given to us to perform binary search. So what is given to you is the sorted list of elements. So you are given a sorted array. Let's assume that the sorted array is A, and this is A, and this is a list of sorted numbers in ascending order. So this is given to you, and you are also given a key element. This is the element key that you are supposed to find in this particular array. So these two things are given to you, the array, sorted array, and the key element. And note that binary search will only work with the sorted array. So with this assumption in mind, we will start with our logic. So the first thing that you do while you look at this array is you have to divide this array into two equal parts, like we have divided the book in the middle, right? So how do you find, or how do you divide this array into two equal parts, or how do you actually find the middle element? So to find the middle element, what you can do is you can actually find the midpoint of the index, right? So starting index is assumed to be as low. So initially low is 0 and upper index or the highest index here is n minus 1. Here in this case n number of elements are 6. Okay, so lower index is initially 0 and upper index is nothing but n minus 1, that is 6 minus 1 is 5. Okay, so this is the initial setup. Lower index is 0 and upper index is 5. If these two indexes are given, how do you find out the middle index? So middle index is called as mid. Okay, let me call it as a mid. So middle index is nothing but low index plus upper index, the high index, divide by 2. I'm trying to find out the midpoint of these two numbers. So it is 0 plus 5 by 2. So in this case it is 5 by 2, that is 5 by 2 is 2. So we are doing integer division, so we write the answer as 2. So this index 2, so I say this index 2 is the middle index, this is mid, okay, and 8 is my middle element. Okay, so first thing is I need to find out the middle element. So I'm dividing that particular array into two equal parts, right? Approximately two equal parts. So in this part, left hand part, there are 2 elements. In the right hand part, there are 3 elements. Okay, so then what you do is once you find out the middle element, so middle element here in this case is 8, right? So a mid is my middle element. Here in this case a mid is nothing but 8, right? So middle element here is 8 and my key element, let it call it as key. It can be any integer number. Now there are 3 possibilities, right? My key element can be equal to the mid element. So key element can be exactly equal to the mid element. Okay, another possibility is that my key element can be less than the mid element, and the last possibility is my key element can be greater than the mid element. Okay, so what I do in step number 2 is I compare the middle element with my key element. Okay, so there are 3 possibilities. So now I need to devise my logic. What happens if my key is less than the mid element? What happens if my key is equals to mid element? And what happens if my key is more than the mid element? Now to understand this, let's take a key to be 20. So whenever key is 20, initially my low is nothing but 0. Okay, the first index, that is index 0, and my upper index is nothing but n minus 1. In this case, number of elements n is equals to 6. So my upper index is 6 minus 1, which is equals to 5. Okay, so upper index is 5, lower index is 0. Now I need to find out the mid index. So how do you find the mid index? I'll use the formula. Mid is lower index plus upper index divide by 2, right? Lower plus upper divide by 2. So this is nothing but 0 plus 5 divide by 2, and this is nothing but 2. So I get this as my mid index. Okay, so I found out my mid index. Now what is my middle element? What is a mid? A mid, my middle element is 8, right? So I write a mid is nothing but 8 in this case, and my key element here in this case already given, it's 20. So I'm trying to do the comparison, a mid and key element. So what do I find? My key element is my key element, that is 20 is equals to 8. No, key element is not equals to mid element, right? But if you can see here, my key element is 20, right? So 20 is greater than the mid element, right? So this condition holds good. 20 is greater than the mid element, so this condition holds good in this case, right? Because 20 key is greater than the mid element, which is 8, right? So that means my key element must occur in the right hand side of this particular list. Okay, so it must occur in this portion of my array, right? If my key value 20 is occurring in this array, it should occur on the right hand part of the array, right? So I'm now not concerned with this value, not concerned with this value, and even with the mid value. Now I'm only concerned with the right hand side value. Now in that case, what happens is my upper index is 5 in this particular chunk of the array, but my lower index now becomes 3, right? My lower index is nothing but the previous mid index plus 1, right? So 3 is nothing but 2 plus 1. Right, so I can write in this case my lower index is nothing but my mid index, whatever was my mid index, plus 1 will give me the lower index, and my upper index in this case is not changed. Upper index is the same one. Okay, it's the old upper index, that is 5 itself. Upper index is not changed, but lower index is changed. Right, now I want to focus on this particular chunk of the array. Now I'll again repeat the same process. I go to step number 1. Okay, I need to find out the middle element. So middle element, how do you find out? The formula is lower index plus upper index divided by 2. So in this case, the lower index is nothing but 3. Lower index is 3 plus upper index is 5. 3 plus 5 is 8. 8 divided by 2 is 4, right? So this becomes my new mid index. This is my mid index. Mid index is nothing but 4. Now once I find the mid index, what I do is you compare the middle element. So what is my A mid now? What is my middle element? The middle element has changed, right? My middle element now is at index 4, I have the element 20. So middle element is 20 and my key is also 20, right? So my middle element is 20. Now middle element is exactly equals to the key element. So I reach to this condition, key element is equals to middle element, because 20 is equals to 20. This is true. So if it is true, what I decide is, now I found my element, right? So if I reach to this condition, key is equals to the middle element, that means I display that the element is found, right? And then I stop my entire process. I need not repeat this process of finding the middle element, dividing the array, and then doing the comparison, because once I find my key element, there is no need to do the further comparison. So I stop my entire process. So in this way, by doing two comparisons, I was able to find out the element 20 is existing at index 4. So 4 is nothing but the mid value, right? So mid is the index where the element 20 was available, because element 20 is available at index 4. Okay, so this is case 2 and case 3 is covered. Now let's try to take an example to cover this case 1 wherein key is less than A mid. Okay, for that let's take the key element to be 1. If the key element is 1, the first step is to find out the middle index. So middle index mid is nothing but lower plus upper by 2. Lower is 0, upper is 5. 0 plus 5 is 5, 5 by 2 is 2. So I find my mid index. This is my mid index, right? Mid index is 2 and my middle value is A mid is 8. A mid is 8 and my key value that's already given to me is 1. Okay, now I go to the condition, right? The condition is I reach here because my key value is 1. 1 is less than 8, right? 1 is less than 8. So I reach to this case wherein key is less than the mid value, A mid. Okay, so in this case, what do I do? Because my key is less than the mid value, that means it must occur in the left hand side. If key is occurring, key must occur in the left hand side in this part. Okay, key must occur in this part, and I can now ignore with all these numbers that's coming to the right of the mid value, and I can also ignore the mid value 8. Okay, so in this case, you see lower index is not changed. Lower index is the same old lower index. Lower index is not changed. There's no change in this, right? But there is change in the upper index. If you see here, my upper index is nothing but my previous middle index minus 1. So it is mid minus 1. Okay, so upper index is nothing but mid minus 1. So this is my upper index now. Okay, new upper index is this one. Okay, this is mid minus 1 because mid was 2. So 2 minus 1 is 1. So this 1 becomes my upper index. So now I am concerned with this particular chunk of my array. Okay, so now I need to repeat this step number 1 and step number 2 because I have not yet found the element. So in this case, I have to find out the middle element one more time. So middle element is nothing but lower plus upper divided by 2. So in this case, the lower is 0. Upper has now changed. Now upper has become 1. 0 plus 1 by 2 is 1 by 2. 1 by 2 is nothing but 0. So this is integer division. Okay, you divide 1 by 2. 2 times 0 is 0 and remainder is 1. So I am concerned about this quotient Q. So here the quotient is 0. So 1 divided by 2 is 0. So my mid index also happens to be 0. Now my mid index is equals to the lower index. So now I find out what is A mid. What is there at the mid index? Okay, A mid. Mid is 0. A0 is nothing but 2. So mid index element, middle element is nothing but 2. And what is the key element? Key element in this case is 1. Okay, now you compare where does it fall. Now you see here key is 1, right? 1 is less than 2 mid element. So it comes to case 1, that is key is less than the A mid or the middle element. So in this case, what you do is lower index will not change and upper index would be the middle index minus 1. So middle index is 0. So my upper index now becomes mid minus 1. So mid was 0, 0 minus 1 is minus 1. Now upper index becomes minus 1. Now this becomes very interesting here, right? Let's note it down. Now my upper index becomes minus 1. So let me write here minus 1 is my upper index. Okay, now if minus 1 is the upper index, what do I do? That means if your upper index is somehow becoming less than the lower index, that means you have checked all the elements in the array, right? So you are going to repeat this entire process only if lower index is less than equals to the upper index. Whenever the lower index is less than equals to upper index, you find the middle element, divide the array into two parts, do the comparison, keep on repeating this process until your lower index is less than equals to upper index. But as soon as upper index becomes less than the lower index, in this case, see, upper index is -1, right? So upper index is -1. So -1 is less than the lower index. Lower index is 0. So -1 is less than 0 is true, right? If upper index becomes less than the lower index, that means you have checked with all the elements, then element is not found, right? So if this is true, you will repeat the process of division and comparison. But if this is false, you will stop, because in that case, now you are guaranteed that your element is not found. Okay? So this is how it really works. Now let us write down our algorithm to perform binary search. So step number 1 is to find the middle element. This is how you find out the middle element. And step number 2 is to compare your middle element with the key element. There are 3 possibilities. So the first case is key can be less than the middle element. In that case, you will update the upper index to mid -1. If key element is equals to middle element, you say that the element is found and then you stop your loop. Okay, and if key is greater than the middle element, then you have to update the lower index to be middle index +1. We have already seen how this works, and we repeat this step number 1 and 2. Keep on repeating this if lower index is less than equals to the upper index. So I can write a while loop here, which will make sure that the loop will run only if lower index is less than equals to upper index. Okay, this is my loop. But before I start the loop, I have to initialize my lower index to be 0. Initially, the first value of lower index is 0, and the first value of upper index is nothing but n-1, wherein n is the number of elements in the given array. Okay, so this is my initialization. This is the condition for running the loop. Now what you do inside the loop, step number 1, you will find the middle element or the middle index first of all. So middle index, let it be mid. So middle index is nothing but lower index plus upper index divide by 2. So this will give you the middle index. Now once you find out the middle index, I'll have to do the comparison, right? I'll compare a mid with key. Okay, so I'll just write if key is equals to a mid. Okay, if it is exactly equals to the middle element, that means I can say that I'm in case this one, right? So I say that element is found. So I'll just write printf it's found, element is found. And if it is found, what I do is I'll have to break from this entire loop because I have to stop now. I did not continue it further, right? So I'll put this entire thing inside a block. Okay, so if key is equals to the middle element, that means the element is found, and then you stop your loop. Okay, and you write else if. So we'll take this case. If my key is less than the middle element, what do? If the key is less than the middle element, I'll have to update the upper index to be mid -1. Okay, I'll have to update the upper index. Else I'm in this case 3, wherein the key element is more than the middle index. So in that case, I'll have to update the lower index. Okay, low is equals to mid +1. Once this is done, what happens is we'll go back and again check the condition. If the condition is true, if lower index is less than equals to upper index, get into the loop, divide the remaining chunk of the array into 2 equal parts. You find the middle element, right? And check the middle element with the key element. If it is found, you say that element is found, and then you stop. Otherwise, you go to the left hand side or to the right hand side. Keep on repeating this loop until your low becomes less than equals to upper index, right? Now whenever the crossover happens, that is whenever this condition becomes false, that means whenever this condition is false, that is lower index is more than the upper index. So if in case after the loop, if in case the lower index is more than the upper index, what happens is now I've already checked with all the elements, the element is not found. So I'll write printf not found. Okay, in this case, I am guaranteed that the element is not found because I've tested or checked with all the elements in the array, and this is where you end your entire algorithm. Okay, so this is the end of the algo. So first you run this loop. Okay, then once you come out of the loop, there are 2 ways you can come out of the loop. One is you'll come out of the loop because of break. If you're out of the loop because of break, there's no problem. You have already printed that the element is found. So in that case, this condition will not be evaluated because this condition is false. Okay, so it will print that element is found. Where is element found? Element is found at index You can also print the index. Index is nothing but mid. It is found at the index mid. But if you are outside of the loop because this condition is false, that means you have tested with all the elements in the array, still the element is not found. So in that case, this condition would be true. If this condition is true, you'll print that element is not found. Okay, so this is how you can actually implement the binary search algorithm. Now we are going to write a code to actually demonstrate the binary search algorithm. So this is a program to implement binary search. Binary search.c is the name of the program file. Okay, and these are the declarations I have done. The array is a, n is the size of the array, I is the index for running the loop, key is the key element that I'm trying to search in the array, low is the lower index, mid is the mid index, and upper is the upper index. Okay, here array input is done. Okay, and now here the real processing starts. First of all, before I start the loop, I initialize the lower index to be the index 0. Okay, the first index becomes my lower index and the last index becomes my upper index. How do I find out the last index is n minus 1, right? Because n is my number of elements. If I do n minus 1, I'll get the upper index, right? Now I'll run a loop, okay, while low is less than equals to upper. Okay, so low must always be less than equals to upper. Okay, so if that is true, then I go inside the loop and I'll perform the division. I'll divide the array into two parts and then I'll perform the division. Okay, so divide the array into two parts and perform search. Okay, this is what I perform. So first of all, I have to find out the middle index. What is the middle index? Nothing but lower index plus upper index by 2. Once you find out the middle index, what you'll do is you'll do the comparison of the middle element with the key element. Okay, so middle element is nothing but a mid. Okay, a mid is my middle element and key element is nothing but key. Okay, so how do I compare? So in the comparison you have three conditions. The first, I'll see if my key element is exactly equals to the middle element. That means I say that the key element is found. So I'll just give a message here, printf element found at index. What is the index? In what index it is found? It is found at index mid. Okay, because the element is exactly found at index mid. Okay, so I'll print the index where it is found, and then because now I have already found the element, there is no need to search it further, so I'll break from the loop. Okay, so this break will take me outside of the loop. Okay, so I can come outside of the loop because of break, that is the element found case. Okay, so in this case my lower index would always be less than equals to upper index. Okay, this is the case whenever the break is encountered. Okay, but else I can have one more condition, that my key element can be less than the middle element. If my key element is less than the middle element, what does it imply is that my key element is at the left hand side. So if it's in the left hand side, I need to update the upper index to be mid minus 1. Upper index should be mid minus 1. We have already seen this. Okay, mid minus 1. Okay, and I did not make any changes with the lower index. Else it means I am at the last case. In this case, my key element is greater than the mid element, right? That means my element is at the right hand side. If the element is at the right hand side, you have to update the lower index to be mid plus 1. Okay, so mid plus 1. And this loop will keep on continuing, right? And there is one more case wherein it can come outside of the loop. It will come outside of the loop if this condition is false. If lower is less than equals to upper is false, that is, if lower is less than equals to upper is false, it can be outside of the loop. Okay, so this is a not found case. Lower is less than equals to upper is false, because this should be false. In there, if this is false, I can write lower is greater than upper, because if this is false, this must be true. So in this case, I need to also print a message whenever the element is not found. Element found message is already printed here at line number 31. Okay, now I'll come down here and then print a message for element not found. So I'll write if my lower happens to be somehow greater than the upper, that means I've checked all the elements, still the element is not found. So I'll just display the message printf element not found. Okay, so this is the message, and then you're done with your program. Okay, but in this case, one thing is very important. Whenever you are taking the input for the array, your array must be sorted. Enter your sorted elements. So I'll just write sorted elements. So I'm not doing a check. I'm assuming that user is going to enter the sorted elements. Okay, that check we are actually not putting in our code, but we are assuming that user is going to print the sorted elements from the input console. Okay, so let's try to compile this code and then see if it works fine. Okay, gcc binary search.c. The compilation is successful, right? Let's try to run this. Okay, enter the number of elements. Let's say number of elements are 5, and let's enter 5 sorted elements. So let's enter 12, 13, 45, 67 and 89. So these are sorted. So let me search for 89. Okay, it says that element is found at index 4. It works fine. Okay, let me give one more time. 5 number of elements. Let's say the elements are 1, 2, 3, 4, 5. I'm giving the sorted elements. Let me search for 1. Okay, 1 is found at index 0. This is working fine. Let me do it for the last time. Let's say 5 elements are there, 12, 13, 14, 15 and 16, and let me search for 17. The element is not found case, right? Enter, it says that element is not found. Okay, so this works fine. So that's all in this lecture. In this lecture, we have learned about binary search. First of all, we started with demonstrating the binary search by really actually tearing off my book, right? That's how we have learned how binary search actually works. Then we have devised our own logic by doing some examples, by taking some example array and some key values. We have written down our own logic to implement the binary search, and then finally we have taken that logic and then implemented it as a computer program, and we have tested that whether it works fine or not, and we have found it that it works well. Okay, so that is all in this lecture. Stay tuned.